There are certain substances in the world whose destructive power is almost unbelievable. They don't just damage things, they overwhelm them completely. Some burn through metal like it's paper, others ignite instantly on contact. A few can dismantle living tissue in moments. Every substance on this list is real, scientifically verified, and documented in chemistry, physics, and industrial safety records. These are 20 substances capable of destroying almost anything they touch. Number 20. Aqua regia. Regia literally means royal water in Latin. It's an extremely corrosive liquid formed by mixing concentrated nitric acid and concentrated hydrochloric acid, usually in a 1:3 ratio. On their own, each acid is already hazardous, but together they form something far more aggressive. What makes aqua regia special is its ability to dissolve gold, a metal famous for resisting corrosion. This happens through a two-step chemical process. First, nitric acid acts as a strong oxidizer, stripping electrons from gold atoms and converting them into gold ions. Normally, those ions would quickly revert back into solid gold. But hydrochloric acid prevents that by supplying chloride ions, which immediately bind to the gold ions and form a stable soluble compound called tetrachloric acid. Because the gold never reforms, the metal continues dissolving. Aqua regia also releases highly reactive gases, including chlorine, which makes its fumes extremely dangerous and corrosive. Over time, the mixture breaks down as these gases escape. While it can remove metal contamination from glass without damaging the glass itself, its fumes can corrode nearby metals, making ventilation essential. One of its most famous historical uses occurred during World War II, when a chemist dissolved the gold Nobel Prize medals of two German physicists to hide them from occupying forces. The solution sat unnoticed on a shelf, and after the war, the gold was recovered and recast into new metals. Despite its power, aqua regia doesn't attack everything. Certain ceramics, glass, and plastics resist it, and improper mixing can cause dangerous reactions or explosions. Number 19. Fluoroantimonic acid. Fluoroantinic acid is widely regarded as one of the strongest superacids ever created. It's produced by combining hydrogen fluoride with antimony pentoxide. The result, ISNT, just aceticates, is millions of times stronger than concentrated sulfuric acid. In the presence of water or oxygen, it's devastating. Number 15. Chlorine trifluorideclin. Trifluoride is one of the most violently reactive substances ever produced. It's a stronger oxidizer than oxygen and can ignite materials that normally burn, including concrete, sand, and asbestos. It reacts explosively with organic matter and moisture, releasing toxic gases like hydrogen, fluoride, and chlorine. Documented industrial accidents show it etching deep into concrete floors. Although it forms a protective fluoride layer on certain metals like nickel, any scratch can result in catastrophic failure. Despite its danger, it's used in semiconductor manufacturing to clean equipment without heat. Number 14. White phosphorus. White phosphorus is a waxy solid that ignites spontaneously in air. Its molecular structure is unstable, making it highly reactive with oxygen. Once ignited, it burns above 1300 degrees Celsius and produces dense white smoke. Burns caused by white phosphorus are deep and persistent because particles embed in tissue and reignite when exposed to air. Medical literature documents the need for surgical removal to stop the reaction. It has industrial uses but must be stored underwater or under inert gas. While metals resist it when unignited, its reactivity with oxygen and organic matter makes it extremely destructive. Number 13. Bromine is a dark reddish-brown liquid and one of only 2 elements liquid at room temperature. It's corrosive, toxic, and highly reactive with metals, polymers, and organic tissue. Liquid bromine causes severe burns, and inhaling its vapors damages the lungs. It degrades rubber, plastics, and oils through substitution reactions. Despite this, it's used in pharmaceuticals, flame retardants, and water treatment. Glass and certain alloys resist bromine, but exposure is extremely dangerous. Number 12. Fuming nitric acid. Fuming nitric acid contains dissolved nitrogen oxides, making it far more aggressive than regular nitric acid. Its fumes are toxic, corrosive, and highly oxidizing. It reacts violently with organic materials, metals, and fuels. Historically, it was used in rocket propellants due to its hypergolic properties. Even small skin exposure causes deep burns. Though some materials resist it, its combined oxidizing and corrosive power makes it extremely destructive. Number 11. Sodium hydroxide. Sodium hydroxide, or lye, is a powerful base used widely in industry. When dissolved in water, it releases intense heat. Concentrated solutions dissolve flesh, hair, and fats through saponification. Lye burns are deep and progressive, as hydroxide ions penetrate tissue. It reacts with metals like aluminum to release hydrogen gas, creating explosion risks. Despite its danger, materials like glass, PTFE, and certain plastics resist it. Number 10. Potassium metal. Potassium is even more reactive than sodium. It melts instantly upon contact with water and often ignites the hydrogen gas produced. It also forms unstable oxides in air that can explode under pressure. Contact with moist skin produces caustic burns. Stored under oil or inert gas, potassium remains stable, but with water, it's instantly destructive. Number 9. Oleum, or fuming sulfuric acid, contains free sulfur trioxide, making it far more reactive than regular sulfuric acid. It aggressively dehydrates organic matter, carbonizing it on contact. Its fumes form sulfuric acid aerosols that damage lungs and infrastructure. While certain materials resist it, oleum destroys organic tissue and unprotected metals with ease. Number 8. Intentionally omitted in original order. Order maintained as per original script structure. Number 7. Fluorine. Fluorine is the most reactive element known. Liquid fluorine ignites organic matter instantly and reacts with nearly all metals. Even noble gases can form fluorides under the right conditions. Only fully fluorinated polymers and select alloys resist it. Number 6. Osmium tetroxide. Osmium tetroxide is highly toxic and oxidizes organic tissue. It damages eyes, skin, and lungs and permeates many gloves. Used in microscopy, it reacts with lipids and double bonds, making it devastating to living tissue. Number 5. Dimethylmercury. Dimethylmercury is infamous for penetrating gloves and skin within seconds. It crosses the blood-brain barrier and causes delayed but irreversible neurological damage. After a fatal lab accident, its use was nearly abandoned worldwide. Number 4. Fluorine. Azotafluorine azide is extremely unstable and can detonate without warning. It reacts violently with organic matter and metals and has no industrial use. Number 3. Perchloric acid. When concentrated or heated, perchloric acid becomes an explosive oxidizer. It reacts violently with organic materials and forms shock-sensitive salts. Modern labs require special washdown hoods due to its hazards. Number 2. Polonium-210. Polonium-210 destroys tissue through alpha radiation. Harmless externally, but lethal when ingested or inhaled. It delivers massive internal radiation doses, as seen in documented poisoning cases. Number 1. Thionyl chloride. Thionyl chloride reacts violently with water, releasing hydrochloric acid and sulfur dioxide gas. It corrodes metals, burns tissue, and produces toxic fumes. Despite its dangers, it's essential in pharmaceuticals and battery production. Its hazards are thoroughly documented, earning it the top spot on this list.